After the discovery of electron, we will see the discovery of proton. Now, proton was discovered by Goldstein. Electron was discovered by Thomson. Proton was discovered by Goldstein. Goldstein discovered protons. Alright? Now, how? Now, see, Goldstein was very clever. He was a very clever scientist. Now, Goldstein was knowing this particular fact that atom is neutral in nature, electrically neutral in nature. Even we also know it, that atom is electrically neutral in nature. Now, electronegative particles was already being discovered. Alright, that is the particles having negatively charged was already been discovered by Thomson. So, definitely Goldstein was knowing about it, that if an atom is electrically neutral, negatively charged particle is already discovered, then definitely there must be some positively charged particles present in it, due to which atom is electrically neutral. And not only he was knowing this, he was also knowing that there must be equal number of positively charged particles. Why? Because minus 2 is there. Now how much you require to make it 0? Plus 2. Minus 2 plus 2 is 0. If minus 3 is there, how much you require to make it 0? Because 0 means neutral it is. How much you require? Plus 3. So this idea was known to Goldstein. For that reason I said Goldstein was a very clever scientist. So he was knowing the fact that negative particles is already discovered. So definitely an atom consists of positively charged particles present in it, and that to equal number of positively charged particles is being present in it. So this idea was known to Goldstein before he started doing the experiment. This idea was there in his mind. For that purpose I said it. Now same thing, you can see this, he took a discharge tube. Alright, same thing, a cathode ray tube, but the only difference is that he took a perforated cathode here, perforated. Now perforated means what? So you can see I have taken a plate. Alright, let us think of, this is a plate is there and holes are present in it. Perforated means holes are present, holes are present. Alright, that's said to be as perforated. So you can see the lines need nothing but represent the holes are being present in it. Okay, so he took a perforated cathode, that's it. Now, and this is same thing, it is connected to a vacuum pump. Got it? I will be taking a gas in it which is at low pressure. The gas is at low pressure, same thing, very very low pressure, 0.001 millimeter of mercury. The gas will be present in it, same setup. The only difference is that we have taken a perforated cathode here. That's it. Now, what you will find it out? What Goldstein observed? When the pressure, now listen carefully, when the pressure was very very low, because at high pressure it is not going to, flow, because in high pressure already I have said you many times that the molecules will be present, and the molecules are the poor conductor of electricity. The molecules of air or molecules of gas, they do not conduct electricity. Remember this particular thing, molecules and atoms are neutral in nature and they will never conduct electricity. Unless and until you won't get the charged particles, it is not going to conduct electricity. Okay, so that you should keep in your mind always. So hence it is not going to conduct when the pressure is higher. When the pressure is very very low, then what will happen is that when you will pass electric discharge through it, the gas will get ionized. And when the gases will get ionized, at that time Goldstein what he saw? He saw that this end, he saw scintillations. Scintillations means same thing, fluorescence. This end, he saw scintillations. Means this end was glowing. Previously, the other end was glowing in the previous experiment, Thomson's experiment. In Goldstein experiment, this end was glowing. So when this end was glowing, the glowing of this particular end, what does it prove? That the rays is passing through this particular perforated cathode, and the direction was of the rays was from positive to negative. Alright, so hence this particular rays was called as nothing but positively charged rays. Alright, and it was also called as canal rays. It is known as canal rays. Why it is called as canal rays? Because it passed through the holes. Like in you can see a canal. You have seen a canal. The canal, the water is being passing through it. So here also same thing. Through these holes, the ions are passing through it. The rays are passing through it. And as a result, we got scintillations here due to this particular reason. Alright, now we did not get the scintillations completely. Here we got the scintillations. Wherever the holes are there, the holes are here, we got scintillations here. The holes are here, we got scintillations here. The holes are here, we got scintillations here. Alright, it's in this way. Wherever the holes are there, we got scintillations, so the fluorescence there. Alright, so as these rays pass through the holes, so hence it was called as canal rays. Alright, so it was directed from the anode to that of the cathode. So it is positively charged. How do we came to know it's positively charged? Very simple. You take that is negatively charged plate here, and you take a positively charged plate here. you will see the rays, instead of passing straight, it will bend towards here, towards the negatively charged plate. How do we come to know? Here you coat with fluorescent substance. Alright, here you coat with fluorescent substance, zinc sulfide, you coat it. You will see this part, it glows. The glowing of this part proves that the rays are positively charged because it bends towards the negatively charged plate. Are you able to understand? The rays are positively charged. How do we come to know? Because the rays bends towards a negatively charged plate. You can say that. The rays is bending towards a negatively charged plate. It's not bending toward positive, it bends towards the negatively charged plates. By that it's been proved that rays are positively charged. Okay? In this way, we got, that is the discovery of the that is protons was being done. Now why it was named as protons, that also let me tell you. Protons has come from the word Proteus, and Proteus means first in Latin language. It means first. You have heard it also in cricket, that is South Africans, they are called as the Proteus because it is believed that South Africans are the first people on this earth surface. It is believed, I don't know whether they are first or second or third. It is believed, historians they believe that they are the first people on the earth surface. So hence they are said to be as Proteus. Alright, so in cricket you have heard it, this particular term Proteus. Alright, so hence it has come from the word, proton has come from the word Proteus. Proteus means first, it is means to say. So hence you can see the protons is being discovered in this particular manner. Now if you see the characteristics of the this particular rays or the protons, you will find it out that it has got the similar characteristics as that of cathode rays, similar characteristics. Got it? Now here I am not using the term anode rays, mind it, I am not using the term. Alright, there I use the term cathode rays, I am not using the term anode rays because anode rays are not produced from anode. Anode rays are not produced from anode. Then how it is produced? See, it is being produced from the residual gas. Residual gas means? See, when the gases is ionized, when hydrogen loses an electron, what do you get it? We get positively charged particles. These positively charged particles travels from anode towards that of the cathode, and hence we got the scintillations. Got it now? It is not produced from anode. So hence we cannot call it as anode rays, this one. Okay? Mind it, it is not called anode rays because it is not produced from anode. It is produced from the residual gas, the gas which is being left out in this particular this cathode ray tube, which got ionized, and hence we got these particles, the positive charged particles, which travels from the anode towards that of the cathode. As the direction was from anode to cathode, in that case you can say it is anode rays. As the direction is from anode to cathode, on the basis of that you can say it is anode rays. But you can't say it as anode rays. Why? Because it is not produced from anode. Mind it. It is not produced from anode. Alright? Understood this particular point? Remember it. Acha. Now, if you see the velocity of the cathode rays and the anode rays, then cathode rays travels faster than that of the anode rays. Why? Because cathode rays consist of negatively charged particles and which has got a negligible mass. While if you say it as anode rays, suppose for the time being let me consider it as anode rays. Alright, then this consists of protons, positively charged particles. Alright, and its mass is quite heavier that of an electron. The mass of an proton is 1.672 into 10 to the power minus 24 gram. How do we find it out? Same method, that is E divided by E by M. Here the value of E by M is different. Alright, the charge is the same. Charge is the same because what I said you in the beginning itself, that he was knowing, who was knowing? Goldstein was knowing that an atom is electrically neutral because it contains same number of positively charged particles. So what is the charge of an electron? Minus 1.602 into 10 to the power minus 19 coulomb. Minus. Why it is minus? Because charge is negative. So what is the charge of proton? Same it is. The only difference is that it will be plus 1.602 into 10 to the power minus 19 coulomb. Definitely, because proton is positive, so it is positively charged. Electron is negative, it is negatively charged. Electron and proton you added, you will be getting neutral, it will become 0. Alright? So hence, you can find it out that the charge is the same. The value of E is the same. The only difference is that in case of electron it is negative and in case of proton it is positive. And the mass of a proton is 1.672 into 10 to the power minus 24 gram, which is estimated that the mass of an electron is, listen carefully, the mass of an electron is 1 by 10 1837 times that of a proton. 1 by 1837 times that of a proton. Alright, the mass of proton is this 1.672 into 10 to the power minus 24. So 1 by 1837 into this value if you do, then you will get the mass of the electron, which is 9.11 into 10 to the power minus 28 gram. So an electron is quite negligible compared to that. The mass of the electron is quite negligible compared to that of a proton. For that purpose, the velocity of the cathode rays is much more than that of the anode rays if you consider. Alright, otherwise the properties is the same. Alright, it consists of positively charged particles. It also ionizes the gases through which they pass. It also causes fluorescence, as you can see. It causes scintillations. It also, falls on the metal plate to causes heating effect. Alright, if you place this mica film, it also rotates because there is an interconversion of energy. Same thing is, whatever the properties of the cathode rays you got it, the similar you will get it for the anode rays of, if at all you say. Got it? Otherwise, I told you that we cannot use the term the anode rays. Generally, we use the term canal rays. Alright? So, in this way, protons was discovered by Goldstein, and this is the mass of the proton, and how we find it out, I said you. Thank you.